Hi friends, good morning. Myself Mr. V.R. Sanap, lecturer in Mechanical Department of KQ Polytechnic Nasik. Today we are going to discuss about the basics of engineering materials. Especially we will discuss about classification of engineering material and its crystal structure as well as unit cell and space lattice. So, engineering materials is the branch of metallurgy which deals with the classification, properties, and application of materials used in industries. Every product given by industry, every machine in industry made of metals, parts made from metal, composite, polymers, etc. in our home makes human life more comfortable and safe. Solid material used in engineering field to cater and serve variety of applications are called as engineering materials. So next, this is the diagram of classification of engineering material. So this material mainly there are four types, that is metals, plastics, then ceramics and others, and composites. So under the category of metals there again there are three types, that is ferrous, amorphous and non-ferrous. Then under category of ferrous material there are steels, stainless steels is there, tool and die steels, cast iron. Then under category of non-ferrous, aluminium, copper, titanium, tungsten and other materials is there. Then under category of plastics there are three types, thermoplastics, then thermosets and elastomers. Then under category of thermoplastics, acrylics is there, ABS, nylon, polyethylene, PVC. Then under category of thermostats, epoxy, then phenolics is there, then polyamides. Under category of elastomers, rubbers, silicones and polyurethanes. Then under category of ceramics and others, oxides, nitrides, carbides, glasses, glass ceramics, graphite, diamond, and last that is composite, reinforce, then plastics, metal matrix, ceramic matrix and laminates. So these are the classification of engineering materials. So next, classification of material based on arrangement of atoms in solid. So again in this diagram there are two main materials, that is amorphous material and crystalline material. So amorphous material have no regular arrangement of their molecules. Materials like glass and paraffin are considered amorphous. Amorphous material have the properties of solid. They have definite shape and volume and diffuse slowly. These materials also lack sharply defined melting point. Then crystalline material. In crystalline structure, the atoms are arranged in a three-dimensional array called a lattice. The lattice has a regular repeating configuration in all directions. A group of particles from one part of a crystal has exactly the same geometric relationship as a group from any other part of the same crystal. Then another classification of material based on arrangement of the atoms in a solid, that is amorphous material and crystalline is there. Uh, so amorphous material have no regular arrangement of their molecules. Material like glass and paraffin are considered amorphous. So amorphous material have the property of solid. Then crystalline, in crystalline structure, the atoms are arranged in a three-dimensional array called a lattice. The lattice has a regular repeating configuration in all directions. A group of particles from one part of a crystal has exactly the same geometric relationship as a group from any other part of the same crystal. Then another ferrous and non-ferrous material is there under the category of metal. Ferrous, these materials contain ions as their main constitute is the ferrous material, and non-ferrous material which does not contain the ions as their main constitute, that is the non-ferrous material. Then again, under ferrous materials, there are two categories: steel and cast iron. So under steel, there are two types of alloy steel: low alloy and high alloy. So again, under low alloy steels, there are three types of low alloy steels, that is low carbon, medium carbon, and high carbon steel. So next category under ferrous metal, that is the cast iron. Again, it is divided into three categories, that is gray cast iron, white cast iron, and alloy cast iron. Under the category of gray cast iron, there is a ductile cast iron, and under the category of white cast iron, there is a malleable cast iron. So this is the classification of ferrous material. Then next, crystal structure. So crystal structure is an orderly arrangement of atoms in a space. Crystalline form a solid has a periodically repeated arrangement of atoms. Normally metals are made up of number of crystals, and each crystal consists of large number of atoms. So crystal structure is the atomic arrangement in a solid. So again, there are three types of space lattices, that is BCC, that is body centered cubic. Then second one, FCC, that is face centered cubic, and last CPH, that is close pack hexagonal. So the first one, that is body centered cubic, that is BCC. So in BCC, each corner atom is shared by 8 adjoining cubes, and atom in the center cannot be shared by any other cube. So this is the BCC structure. Then next, that is the FCC. There is a one atom in the center of each face of the cube along with 8 corner atoms. Each face atom touches its nearest corner atom. So total 4 atoms indicate that the FCC structure is more densely packed than the BCC structure. Example of metals that crystallize in FCC structure are aluminium, nickel, copper, gold, silver, lead, platinum, and gamma ion. So these are the examples. Then next, that is close pack hexagonal. Usually the hexagonal close pack lattice shows two basal planes in the form of regular hexagons with an atom at each corner of the hexagon and one atom at the center. In addition to this, there are three atoms in the form of triangle midway between the two basal planes. It may not be readily apparent from the unit cell why the structure is called as a hexagonal. If a number of these unit cells are packed together with axes parallel to one another, as in a space lattice, a hexagonal prism may be curved out of them. Since each atom at corner of the unit cell is shared by 8 adjoining cells and one atom inside the cell cannot be shared, hence it has total 2 atoms. If 3 cells are considered, then it has a total 6 atoms. So the example of metal that crystallize in this structure are magnesium, then beryllium, zinc, cadmium, etc. So the next is unit cell and space lattice. The atomic order in crystalline solids indicates that small groups of atoms form a repetitive pattern. Thus, in describing structure, it is often convenient to subdivide the structure into small repeat entities called unit cell. The smallest component of the lattice structure is known as a unit cell. The unit cell takes up the shape of parallel pipe. It has 6 faces. The length A, B, and C and angle alpha, beta, and gamma are shown. Then next second, that is the space lattice. It is defined as a 3D geometrical construction which indicates the arrangement of molecules in the crystalline solid. It is also known as the point lattice. It is as shown in figure. Each point in the lattice has identical surrounding and such points are called lattice points. The appearance of lattice point when viewed in a particular direction will be the same to the appearance of any other lattice point when viewed in the same direction. This is identical surrounding. So there are two types of space lattices already we will discuss, that is unit cell and space cells. Thank you very much.